Alright, what is up, future-forward thinkers and 3D design aficionados? Your favorite tech explorer is back. And today, we're ripping open a fresh, piping hot topic straight from the front page of Hacker News. And let me tell you, this one is a asterisk game changer for anyone who touches a 3D model, designs anything in CAD, or, like me, is obsessed with the magic of 3D printing. We're talking about a phenomenal new web tool called Meshdiff. Now, if you've ever had the headache of trying to figure out what tiny, subtle, or even glaring differences exist between two versions of an STL file or any other 3D mesh, you know the pain. Maybe you're iterating on a prototype, a client sent back a revised design, or you're collaborating with a team member. Historically, this has often meant expensive, complex CAD software, importing both models, painstakingly overlaying them, and then trying to spot the changes with your naked eye, or using specialized, often clunky, proprietary diff tools. It's a slow, error-prone, and frankly, frustrating process. But what if I told you there's now a tool that does all of that? Visually, in your browser, client-side, and with blazing speed? That's Meshdiff, folks. And the fact that it climbed to the top of Hacker News speaks volumes about how much this solution was needed. Let's break down what Meshdiff actually is. At its core, Meshdiff is an open-source, web-based utility designed to visually compare two 3D models. You feed it two STL files, or other common mesh formats. Though STL is certainly the most prevalent for 3D printing and many CAD exports, and it immediately renders both models, side by side, or overlaid, dynamically highlighting the differences with a clear, intuitive color coding system. Think of it like Git's --diff command. But for 3D geometry, instead of lines of code, you're seeing changes in vertices, faces, and overall form. Now, the phrase client-side might not sound super sexy to everyone. But trust me, it's monumental here. What it means is that all the heavy lifting, the model loading, the geometric comparison algorithms, the rendering, happens right there in your web browser, using your computer's processing power. No uploading your sensitive CAD files to a remote server. No waiting for cloud processing. And crucially, no privacy concerns about your proprietary designs being stored or analyzed by a third party. This is a huge win for security and data integrity, especially in professional environments. You literally drag and drop, and it just works. So, how does it actually show you the differences? This is where Meshdiff truly shines. Once you've loaded your base model and your revised model, the tool calculates the geometric deviations between the two. It then displays these deviations using a vibrant, customizable color map directly on the surface of the models. For example, areas where the revised model protrudes relative to the base might be colored in shades of red, while areas where it recedes might be in shades of blue. Neutral or unchanged areas remain their original color or a designated no-change color, perhaps gray or green. This visual feedback is instantaneous and incredibly powerful. You can instantly see where material has been added, removed, or shifted. Beyond just color coding, Meshdiff typically offers different viewing modes. You might be able to view only the added material, only the removed material, or a combined view showing both. You can often toggle between displaying the full mesh or just the diff mesh. Some implementations even allow you to adjust tolerance levels, meaning you can tell the tool to ignore changes smaller than a certain threshold, which is super useful for minor, insignificant manufacturing variances or small tessellation differences that aren't actually design changes. This level of control allows users to focus on what truly matters to their specific workflow. Let's talk about the practical applications. Who benefits from this? First, and perhaps most obviously, 3D printing enthusiasts and professionals. Imagine you're printing a complex assembly. You make a small tweak to a tolerance. Export a new STL. And then you need to be absolutely sure that only that tolerance changed. And nothing else unexpected. Meshdiff gives you that confidence. Or, if you download a model from Thingiverse or Printables and want to compare it to a previous version, or a remix you're considering, this saves countless hours of wasted filament and failed prints. Next up, CAD designers and mechanical engineers. In product development, iteration is constant. Design revisions, engineering change orders, ECOs, optimizing for manufacturing, all these involve creating new versions of parts. Being able to quickly and clearly visualize what changed between Design A and Design A_Rev1 is invaluable. It speeds up review cycles, reduces errors, and improves communication within design teams instead of sending lengthy redline markups. You can just point to the visual diff and say, here's exactly where the boss wanted the fillet changed. Then there are game developers and digital artists. When working with complex 3D assets, small changes to meshes can have big impacts on performance or visual fidelity. Ensuring that optimizations haven't inadvertently introduced visual artifacts or that a new animation pose hasn't distorted the base mesh in an undesirable way can be critical. Meshdiff could easily fit into their pipeline for quick sanity checks. And let's not forget architects and construction professionals dealing with BIM models. While STL might not be their primary format, the underlying principle of comparing 3D geometry applies. As design models evolve, verifying that structural or aesthetic changes are precisely as intended is crucial for avoiding costly errors down the line. Now, for a moment, let's geek out on the how.